Here, let's look at this one real quick. Let's look at this one. This is maybe a little easier without the decimals. If the lowest input is negative 1,000, do you all agree that that would give me the lowest output? So they're giving me the range for the inputs. This says determine the corresponding range. If I know the lowest input, this function is nice, so I know the lowest output. What do I cube to get negative 1,000? What do I square to get 100?
110.
What do I square to get 100? 10. So what do I cube to get 1,000? 10. Right? 3 zeros. So I need 3 tens. What do I cube to get negative 1,000? Negative 10. I love it. So what's the range going to be? So far we know it's going to go from negative 10. And of course that's going to be 10. Now I'm going to show you in a minute how that translates to the calculator, right? But this is the work you got to do ahead of time. So what's this range going to be? What did we just figure out earlier? Negative 0.1 up to 0.1. Let me put a little 0 in there. All right. So everybody got that? So I'm going to do this one, and then for homework you guys do this one, right? So let me get my calculator going. Calculator. Everybody's got that. I'm going to switch it over.
What section is that?
Oh, what section was it again? 3.1. Number 85, right? Yeah. Okay. So I know I didn't bring my calculators with me, but just watch. If you have a calculator, you can play along. I'm going to clear out the stuff we did yesterday. Really quickly, I don't know, do you guys see what might be the most interesting button on here? It seems like there's no way in hell. Let me see. There is a freaking math button. Do you understand what I'm saying? If I got this calculator, I never saw it before, there's a lot of buttons that would freak me out, but that would really, really freak me out. I'm like, what the shit is that button? I hit that and all of math just comes flying out of the calculator. If I hit that button, look what I see. What's really useful for me right now, considering the cube root, right? Okay, so if you go to y equals, and you hit math, cube root of x. So that's how you put the function in very quickly. Right? So the math button, I don't know if you noticed, but when you hit the math button, the very first thing is absolute value, right? Okay. So now, if I graph this, I probably got some, yeah. So I have currently negative 10 to 10, negative 10 to 10. So I don't know if you're playing along what you've got. So if you hit zoom 6, that's the standard window. We should all have the same picture. Are you with me? Now, what's really interesting is, remember I told you, how far does that graph go? Forever this way, and how far does it go? It goes forever up and down too. I know it looks like it's really, but it's very small slope, but it eventually gets to infinity. So right now, we're just looking at a small slice of it. What did the problem say for number 86? It wanted the rate, the domain to go from negative 1,000 to 1,000, correct? All right. So watch this. If I go to window, because that's what I think of this. So sort of like if we're all in a submarine and there's a sea monster going by. If I look out one of the little holes, can I see the entire sea monster if it's like right next to us? No. I just see the part the holes look. So I wouldn't have to turn the submarine to kind of like see its head and see its tail and see its feet, whatever. You guys kind of with me? I'd actually have to move the window, which in this case means move the submarine. So I want to move our window. I actually want to extend our window so I can see from negative 1,000 to 1,000. So if I hit the window button, I can change my window. What do I change to be negative 1,000? X. So I go negative 1,000. Don't forget your negative button's way down here. up to 1,000. Now, what did we already figure out our range has to be? It's right there.
Minus 10.
Minus 10 to 10, and it's already minus 10 to 10.
Yeah.
So let's see what we see when we graph this sucker. Graph. Now it kind of fills up the whole screen. Because now this output is this input is the lowest output, this input is the highest output, so it kind of fills the screen. Maybe. Okay, that's all we're doing there. So number 85 works the exact same way. You just make the domain, you change the x-min and the x-max, and then you change the y-min and the y-max. Okay. Is that all right for that problem? Is that better? So the window, when you graph a function, it could be anywhere. So our window might not even see any of it. I might have to move it around to find it. Let's see, any other questions from homework stuff?
Yeah. So, hold on a second. Oh yeah, number 15 on 3-1.
All right, 15 is this guy?
Yeah.
So real quick, guys, can you tell me, why is it really easy to tell that that is a function of x? Does anyone remember? It's solved for y, kick ass. So if you wanted to show that that is a function of y, what would you have to do? Sorry, it's a function of x. You'd have to solve for y. I love it. So on this problem, I have to solve for y. What really sucks about that? How many y's does it look like there are? Looks like there's 2 y's, correct? All right. So let me do a problem like this. Okay. All right, John. I think that's good. Where's you? Where's you? There you are. My one marker that works. Okay. So let's say I have. Don't tell me it's the same one. No. Okay. Sort of is. So what? Whenever you're solving for a variable, where's the kind of worst place the variable could be in the equation? That's a very strange question, I know, but let me just tell you. In the bottom. That sucks. Very first thing I want to do is get my y's up out of the bottom. What do I do to both sides? Multiply by? Negative? No. You're thinking about conjugate. I don't want a conjugate. I just want to cancel this, so that it's no longer on the bottom. So of course I multiply by 3y plus 5, so it'll cancel. So now it's gone, correct? Now the equation looks much better. No fraction, no variables in the bottom. So I distribute, and over here I just have. Now can you get y by itself? How do you get y by itself? What do you get?
Subtract 4y from both sides.
Yeah, you want to get all your y stuff on one side, correct? Yes?
Factor out x on the left.
No, that would be horrible. That would give me back here, and then I can't get y by itself. So, you guys know how to do this. If I'm solving an equation, don't I try to get all my x stuff on one side? Everything else on the other side? Normally everything else is numbers. What am I trying to solve for in this one? I'm trying to solve for y. So I get all my y stuff on one side, get everything else on the other side, right? So this has y in it. This doesn't. this has y in it, this doesn't. So let's say I want to subtract 4y. Great, now this y stuff is together. Oops. What's still in the wrong place?
5x.
Yeah, so now I just subtract 5x. So now I've got 3xy minus 4y equals 1, negative 1 minus 5x. Okay. Now normally, if you're, don't write this down, but normally if you're solving an equation, you would get the x's together and they would be freaking like terms, correct? Then you could just subtract them. Are these like terms?
No, because you got 3xy, not just 3y.
Exactly. But, how many y's do you think there are? 2. There's only 1. So can I undistribute it? Can I factor it out? What do I get when I take a y out?
3x minus 4.
Can you solve for y now? One step away. How do you get y by itself?
Divide by 3x.
Divide by the shit you don't want. Divide by 3x minus 4, right? Did we just solve that equation for y and only get one answer? Sorry, everybody in the back. Talk about using the whole board. That's what I get. Is that solve for y? Is it only one thing, like not plus or minus? Yeah. So is that a function?
Yeah.
Yes, totally. That's going to come up later when we start doing inverses, finding inverses of functions, which is very near in our future. Okay, let me stop for a minute. Whenever it seems like you have more than one letter in an equation you're trying to solve, get everything with that letter on one side, because then you can factor it out. Then there's only one of those, and I just divide by the crap I don't want. It works every time. No? Screw you, Jeff? Okay. So for example, let me give you a slightly easier example. Are you guys still copying this down? All right, let me see. But if I wanted to solve this for, let's see, I'll give you a real equation. Let's say I want to solve that for q.
Minus
Where's all my q shit? Is all the q stuff together?
no.
No. So first thing is, if I'm trying to solve for a letter, if it's in multiple places, get them all on one side, get everything else on the other side. So this guy's in the wrong place, right? So I'm going to add him. So now I get f equals q, q, vb plus qe. Trying to solve for q, it looks like there's 2 q's, but there really isn't. Because can I take it out?
Yeah.
So if I take a q out, do you see how now I can just divide by what I don't want? I can solve for q. So how do you solve an equation for a variable? You've known this forever. Get everything with that variable on one side, all the other stuff on the other side. And almost always, what's the last thing you do? Divide. So I'm going to divide both sides by what I don't want. So there's what q is. You don't have to know this, but this equation is the force that a particle experiences in an electric and a magnetic field. Do you have to know that? No. I'd like to show you. I'm not just throwing letters up here. Sometimes I'm actually giving you real equations. Okay. Yes?
Why did you separate the VB plus E?
Say again?
Why did you separate it by the Q?
Oh, so you're cool up to here, right?
Yeah.
Okay. I'm trying to solve for q. So I need to get q equals. But it's in both, and I can't combine them. So I can take it out. Right? I can factor q out. And then I'm able to divide by that. And that's how you get here. Yeah. So it's really, no, let me show you something silly. You would never solve this equation like this, but if I have this equation, 3x minus 1 equals 2x. What do you do? Yeah, you can subtract what? 3x. All right, I'm going to be silly for a minute. Can I factor an x out? Yes. What do I get inside?
2 minus 3.
And what is 2 minus 3? Negative 1. Now, of course, we wouldn't do this shit. Because 2x minus 3x is negative 1x. But do you see how I don't need to, but that's just a shortcut. I always factor to do that and then subtract or combine whatever I have left in here if I can. Here, I can't. Maybe? Another way to look at it. How many q's are right here? Do you agree with me? There's VBQs. And there's EQs. Do you guys see that? If this was 7, there would be 7 q's, correct? So aren't there VBQs here?
Yeah.
And aren't there EQs there? So how many total q's do I have?
VB
VB plus
plus
E freaking q's. That's all that shit says. That's all it says. So if there's more than one variable in an equation you're trying to solve for, get all of that stuff on one side, everything else on the other side, factor out the bottom. Okay. A lot, get it. Okay. You're all like, you're the only one, Jeff. All right, that's fine. I'm used to that. Okay, that's all I can do for right now. If you have any more questions, come see me. We got to get into some new stuff. There's one idea that comes up in, what was it, section 3.2? Piecewise? Before we do that, can you guys, real quick, how would I graph this using a table of values?
Are you starting at negative 1?
No. How would I graph that using a table of values?
Plugging 1, 0.
Yeah, I agree. You all should know the basic shape of this. But we're going to hit new functions this semester, so we're going to remember how to make an XY table.
You would input, so let's say we're starting with 0 or 1, whatever.
Let's
number
put
you
some
want to
negatives. So
start
I always put some negatives, 0, and positives.
with. Okay. So you
This
would,
is the least ones I always use. I might use more if I still don't know what this shit the thing looks like.
So then you're gonna input negative 1 into the x value.
So what's negative 1 squared?
1,
1 minus 1?
0,
0.
0 squared?
0.
0 minus 1?
Negative 1.
1 squared?
1.
Minus 1?
0.
0. So you can see, of course, the idea of a parabola is going to repeat outputs because it turns, right? So I expect to see this somewhere in my table. We got it right away, of course. So then I would plot negative 1, 1. So it goes negative 1, 0, 0, negative 1, and then 1, 0. And then there's my yeehaw. Okay, absolutely amazing. So you all should be able to eat that shit up, right? I could give you almost anything I want to here and say plug some stuff in and give me a graph, right? Just got to plug points, plot them, connect them, right?
Yep.
This semester we're going to add to our repertoire of what functions look like. You all know x squared looks like this. If you don't, now you do. We all know this. So throughout the semester we're just going to add to that list of stuff that we know what it looks like. I don't know if you've ever seen, there's a shirt that I really want to get, but I've seen it. And it's got this guy doing all these dance moves
yeah.
related to the functions. So he's like, this is the parabola and this is the cube. Okay. All right. So, do you all agree with me that if I throw a ball in the air, it follows a parabola? You all agree? So there would be an equation that would govern how that ball is moving. Not govern, it describes how the ball is moving, correct? What if the ball hit something right here? Would it continue on its same trajectory?
No.
No. It would if it hit something, it might drop, or maybe it'll hit something and slow down, so it'll come to the ground faster. Do you agree? So there'll be a moment when my first function stops being true and a new function takes over. Does that make sense what I just said?
Yes.
Yes. Kick ass. That's why these crazy ass things exist. So let's say I throw a ball up in the air and at 4 seconds it hits something. So up until that time, it looks like, what do you got, Jeff? This. We'll make it easy. So let's say I'm throwing it off of a cliff. That's better. So here's Jeff on a cliff. There I am, and I throw something. So it's going to look like it's going to try to go like that. Yes? That looks like part of a parabola. You guys agree? And it's a down parabola. How do I know from the equation it's down? Because the x squared piece is negative, kick ass, right? But let's say right here, there's a, I don't want to say a bird, poor little bird. I don't know. There's another ball somebody threw and it hits, and my ball hits their ball. So my ball then changes trajectory. Are you guys with me? So now let's say at that point that my ball, oh wait a minute, make this 3, sorry. There we go, okay. Let's see, yeah, it does this. You know what I mean, so I gotta think about this. Yeah, that'll work. So I want to plot this thing. So what I do, what I try to get people to do, is how many different functions are actually made, kind of put together for this one function? 2. So I'm going to make 2 xy tables, right? I'm going to have an xy table for 16 minus x squared. What kind of inputs work for that one? What inputs work for that function? Nope.
Oh, you're gonna.
Yeah, so in general, all real numbers, but this specifically says only 0 to 3. All right, so cool. So then I know what to input, right? And then, when does negative x plus 10 take over?
3 doesn't work, right?
Yeah, good point. I'm going to talk about that in a minute. Negative x plus 10 takes over at 3, so I can put a few more things in after that. Okay. This one is not allowed to be used in that function, but I still want to know where to put the open circle. See if this makes any sense. If it was just that, could I put a 3 in there? If it was just this function, I could put a 3 in there, correct? Officially, I'm not allowed to use 3 because it doesn't work at 3. This guy takes over, right? But I still want to know where to put this guy's open circle. I still got to see where it would want to be. So what I do with my table then is I normally do this. So that's not allowed to be input into the function, but I need to so I can see where the circle would go. So what do I want to put a 0 in?
16.
16. 16 minus 1, 16 minus 4, 16 minus 9. So there's going to be an open circle at 3, 7, because this guy is not allowed to exist at 3. Somebody takes over at 3. Do you guys see that? Let me try this again. Is everybody cool with these numbers? Beautiful. Doesn't this function work for 2.9? Does this function work for 2.9? What about 2.99? What about 2.99999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999? What's the function? 16 minus x squared. If I plug a 2 in, what's 16 minus 2 squared? 16 minus 4. Yeah. So I'm just inputting these inputs and I'm seeing what I get out. Okay. So that describes what I'm allowed to use, including the one I'm not allowed to. But I don't want to put 2.9999999. I don't. So I'm just going to put 3 in and see where the circle's going to go. Over here, when I put a 3 in, what do I get?
7.
What do I get when I put a 4 in?
6.
6. 5. 5. Okay. So let's see. What is this thing going to look like? So I go from 0 up to 5. And I want to get up to 16, right? So what scale could I use here?
2, 4, 6, 8, 10.
Yeah, let's use 4, 8, 12, 16.
Okay.
points in here if you want. And then you start plotting points. 0, 16, 1, 15, 2, 12, and then 3, 7 is going to be an open circle. Yeah. Get in there. So that is this guy's contribution. The ball starts going like this. Then the other ball kind of hits it. And now it takes a different trajectory. It takes this trajectory. So now it's going to go 3, 7. See how that fills that hole in? It doesn't have to. But here it makes sense physically. I really want you to, when I start to plot this one, 3, 7 fills that hole in. You see that? It doesn't have to. It could actually jump mathematically, but physically it makes sense it should fill it in. 4, 6, 4, 6, 5, 5. So now it takes like that. So I threw a ball down, it went, somebody else threw a ball up and it hit, and now my ball goes like that. Alright, maybe. So the biggest mistake people make when they graph piecewise functions is they graph this function way too far. So I'll get somebody to do something like this. And then they'll also have this. Is that a function? No, because it doesn't pass the vertical line test. So one function has got to stop and another function takes over. You don't graph the whole thing. So that's why I highly recommend you make a table of values going up to the highest thing you're allowed to use and then start for the next guy. How are we doing out there? Have you guys ever seen piecewise functions before? Yes, okay. Let's do one more.
How
Yeah.
about the 60 on 3, 2?
Let's see. Oh, no, so well, okay. We can do that in a minute. It's not a piecewise. This one here?
Okay. Yeah, that one.
Is that right? That should be true. All
I
right,
just
we'll do
wanted
that
to
in a
make sure I
minute.
got it in there before I forgot about it.
No worries.
Okay.
Let's try a different one here. So try to make your two tables. You can use like 3 points because you all know the shape of those. So the more you know the shape of a function, the less you need points. I just need a few points and then I can put the shape on top of it. Try to make 2 tables for this. While you guys are doing that, did anyone not get their quiz back yet?
Yeah, so let's go to that, and you can make corrections.
Sure. I know. Swirling, but get this in my head. So it's curved a little bit, and make corrections. Alright guys, let me catch up to you. So 4x, that's just a straight line. I don't need a ton of points. Can somebody tell me a few inputs that I should use?
-1, -2, -3.
Alright, let's do this. Let's start at -2, -1. There's one more I have to use. 0. But again, we remind ourselves, oh yeah, it can't exist there, but I need to know where to put the open circle. Okay. You can put in more than this if you want to. You know you at least have to use this guy and then use a few more in that direction. So 0, -1, -2, that's beautiful. So when you put a -2 in, what do you get?
8.
-8. -1, you put
-4.
-4, 0, you would get 0. So it wants to be here. It just can't. So we're going to put an open circle there. So what's the other table? It's going to relate to this function. Somebody give me some inputs for that. 0, 1, 2, 3. Sure. I love it. Definitely start at 0. And it's allowed to use 0. Good for him. So when I put a 0 in, I get -1. When I put a 1 in, I get 0. When I put a 2 in, I get 1. When I put a 3 in, wait, Jeff, not
3.
1. 3. When I put a 3 in, you get 8. Let me stop for a minute. Does everybody see how I came up with some inputs? Do you have to use exactly these? No. But you know you have to use 0. So you can see how it kind of hands off to the next function. You see where it ends and where the next function begins. And then you just put some more stuff like in the right direction, below 0 in this case. 0 and then above 0. So now you just got to worry about scale. X-axis is pretty easy scale. What scale should you use for the y-axis, maybe?
4, 8.
Yeah, you can do, let's do 2, 4, 6, 8. Well, that's a choice you can make. All right, let me stop for a minute. So really quick, the scale must be consistent. If you say a tick mark is 2, it better keep on being 2. Do you notice that the y-axis scale does not have to be the same as the x-axis scale? Thank the gods. Because that would be crazy if it had to be. So now you just start plugging points in. What's it look like below 0? What's the shape? Below 0, what's the shape? Below 0, what's the function? 4x. What's the shape of that? A line. Okay. Above 0, what's the shape? Above 0, what's the function? X squared minus 1. What's the shape of x squared minus 1? Yeah, it's a parabola. It's got to be curved, right? So if you have a power that's not 1, if you have any other power in your variable that's not 1, you're going to end up with some kind of a curve, right? Squared, cubed, right? You can get cube roots and get some really weird, we did the cube root function earlier and it was like this. Okay, stop for a minute. I know you guys all know this. You just freaked out about the piecewise right now. You know what squares look like. Obviously you know what lines look like. You might not have known what my question was all about. So -2, -8. You gotta go down here, Jack. -2, -8. -1, -4. And 0, 0, there's going to be an open circle, so it looks like this. Notice I'm putting an arrow because it's allowed to go forever. So that's this part. Goes up to 0 and doesn't quite get there. And then this guy takes over. Where does he start? 0, -1. 1, 0. 2, 3. 3, 8. So then it becomes this. You guys with me? You would never connect a straight line there because you know it's not straight. It's squared. It's going to be curvy. Yeah.
Because the 0, 0 is the open circle, that passes the vertical line test, right?
Totally. I love it. Kick ass. It's almost like a planet there. Why does it still pass the vertical line test? The only place it might not pass is right here, but it only exists there. So every vertical line would only go through once. If you put a closed circle in a closed circle, you just grab something that's not a function. Freak it out. Okay. This doesn't make very much physical sense. Do you agree with me? This is like some Star Trek shit or something. Running along and then they get transported down or something, right? Or portal, or whatever your preferred teleportation thing is. Okay.
Stargate.
Sure, Stargate. That'll work. All right. Or to fly even. Ooh, get some more. Yes.
And I would just like negative point 0.00001 is part of the first function, but just the one is not.
Let me catch up to you. Negative point. Oh, yeah.
Infinite 0, 1,
Anything that's less than 0, I could input.
and then right.
Do you really want to input negative point 0.0000001? No. So what I do instead is just put 0 in. I'm not allowed to. So I'm not going to plot this, but I'm going to put an open circle there. That's where it would want to go. Where would negative point 0.00001 go? Right there. Right? But it has to be defined there. So that's why I want to know where my open circle goes, because then when I make the line, I'm saying it's defined everywhere up until that circle. Yeah. Okay. Because I'm allowed to use every input up until that circle. Okay. So there's a piecewise, not pennywise. No floating. Yes.
Weird question. Is piecewise IE or EI?
It was IE.
Okay.
I like it. I before E except after C, except all the other times it's
Yeah.
that. Yeah. The rule doesn't really hold. I love it.
Neighbor and right.
Okay. All right. Enough of that. So one thing I want to focus on today is shoot, I forgot what's on. Oh yeah, okay. We pretty much did all of section 3.3. The one thing, because this is where we talk about increasing, decreasing functions, we talked about finding the local max and local minimum, right? So we talked about that kind of stuff. The one thing we haven't talked about yet is what's called rate of change. I also call this, have you ever heard the expression as the crow flies?
Yeah.
Has anyone never heard that expression before? As the crow flies? So what that means is, if it was physically possible for me to just go straight, how far is that? So when you look at Google Maps, and it tells you the distance, it's obviously not the actual physical distance, because we're going to have to do this weird-ass trek along the roads, yes? We're not going straight. But if we were able to fly there, how far would we actually go? So what this is this. If I were, let me ask you this. If I take off in a car, and I maintain a constant speed, how is my position changing? If the speed I'm going is constant. Right, so let's say that I'm going 1 foot per second, right? So if I start at 0, 0, after 1 second, where am I? Yeah, so this S normally means position, and T, of course, means time. So after 1 second, I'll be 1 foot away. After 2 seconds, I'll be 2 feet away. Are you guys all with me?
Yes.
Okay. I like it. So really quickly, this one's kind of a silly example because it's a linear function. So the average rate of change, we already know what the average rate of change is. For this function, how much does it go up over time? Well, every second it goes up 1 foot. So it's sort of like an idea related to slope. If it's a straight line, it really is just the slope. So when we say slope, we're really saying the average rate of change. How quickly is the function changing over time? When it's a straight line, easy. So this would be 1 foot per second. So what if it's not a straight line? Damn it, Jeff. What if I had this function? Yeah, let's just do x squared. Doesn't matter for negative. So I have this function, bam, 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 bam. I'll just draw this much of it. And I want to know what's the average rate of change from zero to 2. This one's not as easy because I don't know what the hell the slope is. In fact, you guys all agree with the slope is constantly changing?
Yeah.
Real quick, some of you guys are going into calculus. Calculus is going to study how do you actually tell what the slope is at every point then. For a line, it's easy. It's always just a number. For anything that's curvy, it's constantly changing. So calculus, really, the fundamental heart of calculus is the study of the slopes of things that curve, right? That's all calculus really is. You do a lot of shit with that, don't get me wrong. So it's not a straight line, it's curvy. So if I'm at 0, where am I? We are where? We are at
The origin.
0. Cool. So at 0, we are at 0. Purple, I'm sorry, dude. You're just not. Sorry, dude. At 2, where am I?
4.
Yeah.
Alright, so I'm at the point from 0, 0 to 2, 4. So as the crow flies, let's see if this makes more sense. If the crow flew over this road, it would just go wee-haw. Or it could, let's say. I don't know what the hell it would do. Just go to the shiny thing. You guys got it with me so far? Here's the road. We got to do this shit. Bless you. So in 2 seconds, let's say this is still seconds, and let's say this is still feet. In 2 seconds, how far did we go? 4 feet. So how fast are we moving then? We went 4 feet in 2 seconds. So what's the average velocity? What's the average rate of change? And do you see how it's really just the slope? 4 minus 0 over 2 minus 0. 4 over 2 is 2. And with the units I gave us, it would be feet per second. Were we constantly going 2 feet per second? Where are we going the slowest?
0,
0, 0. And then we speed up. Don't we speed up? All right, maybe. Are you guys semi with me here? So it's the idea of slope, but applied to curves in a very crude way. We're just saying, take 2 points and just see what would the straight line be. So it really is just finding the slope. So let me do this without graphing. They give me a function. Sure. And they want to know the average rate of change from -1 to 1. Sure. What do you get when you plug -1 in?
Negative variable 0.
So let's see, 1 minus -1 cubed. What's -1 cubed?
Negative 2.
What's -1 cubed?
Negative
Negative
1.
-1. 1 minus -1,
Negative
2. What do you get when you plug a 1 in? 0. Right? This is x, correct?
Yeah.
What's this? What's my output? We always call it what?
X cubed. Oh, 1 minus.
Input is x. Output is
Y.
y. Good. What's the slope function in general? Do you guys remember what the y's and the x's? Slope between 2 points? I'll get us, yeah, y2, y1 over, yeah, change in y's divided by the change in x's. Yes?
Okay.
Yes. So what I'm saying here is, to find the average rate of change, y is going to come from f. How do I get that y? Don't I plug x in? How do I get that y? Don't I plug x in? So any function I give you, you do not have to graph the damn thing. You can actually just use this directly. Average rate of change is the slope if I was going in a straight line. And that's what you could use. So this would equal f of 1 minus f of negative 1 over 1 minus negative 1. The difference in the y's, the difference in the x's, the difference in the outputs divided by the difference in the inputs. So what was f of 1? 0. And what's f of negative 1? 2. And then negative 1, I'm sorry, 1 minus negative 1 is 2, so I get negative 2 over 2 is negative 1. So the average rate of change is negative 1. Okay, maybe. So this is the average rate of change formula. It's just the slope formula. Where do I get outputs from? By putting stuff into my function. So I can write y in a better way. So now whatever function they give you, just throw in the numbers they give you for x, divided by the difference in those. You're just finding the slope between those 2 points. Okay. David? So that was the one last idea in section 3.3 we hadn't discussed yet. And here it is right there. Right there. Okay. So you see a few problems they ask you. They give you a function, then they say, what's the average rate of change from x equals 3 to x equals 7? Well, you just plug stuff in. Okay. Gotta be all crooked. Let's see. So the next section, we already discussed composition of functions a little bit. We had a couple examples on that one worksheet we worked on. So if I said f of x is x squared plus 4x, and I say g of x is x minus 1. Real quick, what would f of 1 be?
1 squared is 1.
Yeah, you plug a 1 in for x, right?
Plus 1x. Oh, 1, 1.
1 plus 4.
Yeah.
Okay. Right? You just plug. The beautiful thing about functions is they're very single-minded. Whatever's inside of them, you just plug it in. So help me out. What would g of w be?
W squared.
No, g of w.
Oh, G.
W
Oh, x
W minus 1.
minus 1. Okay.
Whatever's here, you put it there.
Right.
Yeah?
Right, okay.
That's the basic idea of function notation. So what the hell is this? What do you got, Jeff? F of g of x.
It's,
What am I putting where?
you're putting, when you find g of x, you're putting that into f of x.
I'm putting g into f. So let me do this for myself. F of x minus 1, right?
X minus 1 squared?
So wherever you see an x in f, I'm going to replace it with this. Do you guys see that?
Yeah.
This is what's called composition of functions. It's composed of more than one function, right? So when I throw an x in, an x minus 1, I'm going to get x minus 1 squared
Yeah.
plus 4 times
X minus
x
1.
minus 1. I'm just going to do the same shit we would do if it was 7. We would throw a 7 in. Well, now it's x minus 1. Okay, I'm going to throw an x minus 1 in. Now, of course, you can simplify this a bit. X squared minus 2x plus 1 plus 4x minus 4, blah, blah, blah. You put your like terms together, what do you do? That's what's called composition of functions. I spoiled you guys. We're not going yet. So the last thing I want to say today, like forever, no. Last thing I'm going to say today is this here. Does anyone know what this function looks like if I graph it? Anybody know what the shape that has? What's the smallest number I could put in there and make it real? Because I don't want to graph complex numbers, unless you do. 0 down for that shit. Let's not do it. Yeah, the lowest thing I put is 0. So let's make a little table of values. 0. Help me out. 1 makes sense. 1's good. Do you want to put a 2 in, considering we're doing this shit by hand? You understand what I'm saying? So you can be smart about your inputs. I just got to get a few points and then connect them. I don't have to use every single input. I don't have to
0,
put
1,
0.7.
4.
4. Good. So 0, square root of 1 is 1, square root of 4 is 2. So it looks like this. 0, 0, 1, 1, 4, 2. Notice it looks like a parabola that fell out and then lost its bottom half. It had a bad or a good night. I don't know. You guys kind of with me? Okay. What do you think happens if I make the function this? So let's think about it for a minute. Is that plus 1 affecting the input or the output?
It goes so left.
Is that plus 1 affecting the input or the output?
The output.
What is it next to?
The input.
It's next to the x. So let me ask again. Is it affecting the input or the output? Input. If I plug a 0 in, I get a 0 out, correct? And that's the lowest thing I can plug in. Can't I plug in something lower than 0 here?
No.
Yeah, I totally can. I could plug a negative 1 in, yes?
Well, then you get I.
No. What's negative 1 plus 1? 0.
Oh.
Not make this negative 1. I could plug a negative 1 in. What's the very first thing I do to any number I plug in that function? What's the very first thing that function does? Adds 1. So can't I have 1 less than I used to have? Can't I plug in 1 less? So what did I used to have to put in here to get a 2 out? What did I have? I had to put a 4 in, correct? Now what do I put in to get a 2 out?
3.
So visually what's going to happen is the damn thing is just going to move back 1. Because now when I plug, this is where I need more than 1 color. I really don't have it. Now when I plug a negative 1 in, don't I get a 0? So see how that one just went back 1? That one, now when I plug a 0 in, don't I get 1? That one back 1, so this goes back 1. Every point just goes back 1. So what if I would have put a plus 2 there?
It will go back 2.
It would just go back 2. So if I know this basic shape, do I have to make a ton of these? No, I just move that shape around. Yes? Do you understand what I'm saying? So we're getting into something called transformations of functions. So it's where I move it left and right, I move it up and down, I can stretch it, I can smoosh it. Yay! Okay, that's enough. All right, guys.
So what about 60 and 31?
Oh yeah, I'm sorry.
No, 31.
I have 3 1.
Oh, wait.
What do you mean 3 3? Which one? The ones I just
Let
did?
me see.
Oh, this one here.
3-2.
Yeah, this one.
Yeah.
So for this one, domain of the function. Mike, is there any number I can't square or add? Is there any variable on the bottom? Is there any variable inside of a root? I'm allowed to plug in anything I want to mathematically. Now, let's see, blah, blah, hey, T seconds, T seconds. What do you think? If I throw the ball 1 second later, T is 1, correct?
Yeah.
So what's T equals 0?
Before I throw it.
Good. Could there be a T equal negative 1?
Well,
Physically. Mathematically, yes. Physically, that doesn't make any sense.
what I'm thinking about is, okay, if it's ICBM and it's in the silo, it hasn't actually come out of the ground yet.
So T equals 0 is the beginning.
It's like T minus 1.
Beautiful. T minus 1 means before the function has started
Or the
happening.
launch, yeah.
Nothing's moved yet. T minus 1. So T equals 0. So the domain for this physically is 0 up to something. Right? So that's the point they're trying to make, is mathematically the domain is all the numbers. Physically, I'm going to start at 0.
Okay.
Okay.
Do you know what the axis
classroom sometimes, but also I'm in my office. So you what? Oh, did you check to make sure? Oh, there's a mistake on the end there.
Okay.
You see how like, you don't get the 3 lines?
Oh, yeah.
And also the last one always positive.
Okay.
This one, oh, here. I is not 1. I is the square root of -1, so we just leave I alone. I squared, we replace it with -1, because I squared is negative.
Okay.
I is some freaky thing squared in -1.
Okay.
Yeah.
Sounds good. Thank you.
Which one? Oh, look here. But no, but what are you doing in there? Are you kind of like testing combinations? Where did 12 come from? The 4. Okay, good. So just capture that. And when the numbers get grosser, you can always do it in your head. That's what I'm trying to get at. Yeah. Yes. Thank you. Oh, this works directly if you know what those are on the outside. I don't see how you determine what those numbers are. I don't see how you got, where did 8i and 3i come from? Those weren't there. Do you understand? This is all you know at the beginning. The 3 and the 4 doesn't exist at first. Do you understand? So how did you know this was a 3 and this is 4? Why isn't this a 4 and this is a 4? Again, the outside of this would be blank at first. They don't exist. They are the answer. That's what you come up with. How did you know that would be an 8 and that would be a 3? So if I gave you multiply this times this, you would put one of them on the outside and one of them on the other outside, right? You don't have that. You are determining what they are. My question is, how did you know that's what these are? That's the work I need to see. Why was that an 8 and that was a 3? Why not a 4 and a 6? Okay. Why not a 24 and a 1? Yeah, that was a thing. I'm all joking with it today. I just will not. This guy goes straight. Oh no, the overhead thing. Oh yeah. No. Got you. Got you. I should say that's what I'm doing. So. No, like, I guess we can let that go. Oh, what's up?
So the homework is just for that section, it's not
How do you mean?
the review questions for the whole chapter? It's like, for the 1.5 homework, I ended up doing the review questions for the whole.
I don't know what you mean, so.
Like, so this is all of chapter 1.
Why? So
It's only 1.5, the section of 1.5.
Yeah,
Oh,
yeah,
okay, all
yeah.
right.
Be good.
Yesterday,
Yeah.
I got a flat.
Oh, yeah, yeah.
Stranded on.
I got you.
I Ubered you. I Ubered you.
I might not reply because you didn't ask me a question. I just made a note. But you know, the video is up on YouTube.
Oh, no, for the quiz.
Oh, these quizzes, I just replaced them with a grade on the next one.
Oh, okay.
So it won't be a 0, it will just be whatever you put in next time. Yeah.
Okay, thank you.
I'm still recording. That's an